So now I'd like to say, why is it so personal to me, this whole thing? This is a picture of me when I got my MD, so that's a PhD in medicine. It's 1981, and on my right, on your left, is my father, and he has just been diagnosed with type 2 diabetes at my age. I'm his age in this picture. He's 66. He's just been diagnosed with type 2 diabetes. He has high blood pressure, and within 6 years, he will lose his foot. Within 8 years, he will lose both his legs and lose his mind from the disease. So now the question is, am I going the same route? In 6 years, will I lose my foot? In 8 years, will I lose both legs? That's why it's important to me. But it's not just personal, because diabetes is the biggest challenge we face in the world, in medicine. And I'm going to show you that my father has a condition, insulin resistance, which I have, which is the most prevalent medical condition in the world, and we don't teach it in our medical schools. And that is wrong, and that's partly why I'm here. Now, I know exactly what evidence my father was given, the advice he was given, and I'll show you how I know. What no one knew was that he had what's called a fatty liver, and that his arterial disease, from which he died, as I'll show you, he didn't die because he wasn't getting enough glucose to his brain. He died because he had a disseminated arterial disease, which is the cornerstone of diabetes. Diabetes is a disseminated arterial disease. And we know now it begins in the liver, and it begins when the liver is full of fat. That's called a fatty liver, non-alcoholic fatty liver disease. Had I known, and we'd examined him, we would have seen that he's got a fatty liver, and he's got certain cholesterol abnormalities. They're called lipoprotein abnormalities, which are specific to the non-alcoholic fatty liver disease. And we could have treated him, because what he needed to do was the opposite of the advice that he was given. So what advice was he given, and how do I know it's true? Well, here's the book written by, and please understand, I do not hold this lady accountable at all. For one moment do I hold her accountable. She's a friend of mine, and she's a great friend of mine. Her husband's a great friend of mine. She did nothing wrong. Absolutely nothing wrong, and I'm apologizing that I have to show her name, but she did nothing wrong. She did what she was told to do. And here she gave me this book, and this is 1990, and that would have been 9 years later, 2 years before my father died. And she said, "Tim, thank you very much indeed for your ongoing support for the development of dietetics at the University of Cape Town." That's important. I was driving the development of dietetics at the University of Cape Town. So people might think that I'm anti the Dietetics Association. No, I was involved in its development at the University of Cape Town. It really is appreciated enormously, and no, I don't get royalties from copies sold. And so why did she put that in? Because who's funding the book? SA Sugar Association. So this is a theme that we're going to come back to perhaps. And you'll notice that there's a whole story there about sugar. Is it okay to eat sugar? And then as far as sugar is concerned, and you've got to eat a moderate, balanced diet. And so that's kind of a theme that comes through. And I'm not trying to say that there is a conspiracy or anything. I'm just noting the fact that this book was funded by SA Sugar Association. Now we move forward. So my father dies from disseminated arterial disease of diabetes, not because he hasn't got enough glucose in his body. This lady is a registered dietitian in South Africa. She's a member of ADSA, and she's written this book for diabetics, and any of the books that I can show you about diabetes in South Africa will be the same. So this is the theme. Carbohydrates are an important source of energy in the body, and glucose, which is the product of the digestion of carbohydrates, and then in red, is the only energy source for the brain. And that is utterly, completely false. It is therefore crucial for diabetics to include carbohydrate-rich foods at each meal. So we have a wrong assumption, which has to lead to the wrong advice. So the hypothesis then on which they base the treatment is, so when prescribing diets for persons with type 2 diabetes, the sole consideration is that the brain requires glucose for its function. That's the advice. Let's go back to it. It's the only source of glucose for the brain. Glucose is the only source for the brain. So the logic is, therefore, we must prescribe carbohydrates for our diabetic patients. so that their brains will continue functioning. But what about the effects of different types and amounts of carbohydrates on blood glucose and insulin control, which is what the problem is in diabetes? It's not that the brain's not getting enough glucose, it's glucose control, and particularly insulin response. And then more importantly, to the development of disseminated arterial disease, it's the key pathology in diabetes. And it's the key pathology that is killing us. At this moment, someone in Cape Town, there are 300,000 diabetics in the Western Cape. At this moment, one of them is losing his or her leg, this moment. And what are we doing about it? That's the question. So, she continues, for effective blood sugar control, it's important to understand that different carbohydrate-rich foods have different effects on blood sugar levels because of the difference in their glycemic index. Okay, that's technical. We're not going to worry about that. But treating the blood glucose concentration, which is what that's all about, treats the symptom of the disease. It doesn't treat the cause of the disseminated arterial disease that killed my father and that will potentially kill me. It's not treating the cause of the problem. So what she should have said, this, for effective blood glucose control, it's important to understand that carbohydrates should be removed from the diet as they are non-essential, and persons with diabetes are unable safely to metabolize carbohydrate. And had my father been given that advice, and had I known, maybe the outcome would have been different. And it is my responsibility as someone with type 2 diabetes, my understanding of the biology of the human body, my personal experiences, my job is to make sure that that message gets out to the world. And I'm very encouraged because today, one of the tweets I didn't show you comes from Australia, where they banned a lady dietitian for treating diabetics with a low carbohydrate diet. The central science body today published an article saying low carbohydrate diets are remarkably effective in the management of type 2 diabetes. So Australia is changing, and the rest of the world will have to follow in due course. So the reason why limiting carbohydrates help, and I will show you, is because limiting dietary carbohydrate reduces the excessive insulin production. And that is the key problem in diabetes, is that we oversecrete insulin and the insulin doesn't work because we have insulin resistance. And it's the insulin that causes the disseminated arterial disease, which is the defining pathological feature of type 2 diabetes. And that conflicts with the theory that it's cholesterol which drives arterial disease, and that model I will show you is incorrect. It is lipoproteins, absolutely, which drive coronary artery disease and arterial disease. But that lipoprotein abnormality arises in the liver that has non-alcoholic fatty liver disease. In other words, it's a fatty liver, and that is caused by a high carbohydrate diet. So it is carbohydrates which act through the liver to cause arterial disease. It is not fat, saturated fat in the diet. And I will spend a great deal of time showing that. So when a human ingests carbohydrate, I will show you that in my view, it's not what we were designed to do, but I'll have to present that information. And because we cannot allow the glucose in the bloodstream to rise excessively, and because we only have 5 grams of glucose in the bloodstream, and we eat 100 grams at a sitting, suddenly you've got this 100 grams of carbohydrates which got to be stored in a blood system that can only take 5 grams. And you have to ask the question, if glucose is so essential to humans, why do we only have 5 grams in the bloodstream? So you've got this 100 grams trying to stuff itself into a space that it only take 5 grams. And the response that the humans have evolved is to secrete the hormone insulin. And insulin drives the glucose, as I'll show you, into the fat cells, particularly, including the fat cells in the liver. And that then brings the glucose down. So hyperinsulinemia is a state where the insulin is higher than it should be in response to the glucose challenge. And one of the key differences in people today, the way we eat than we ate in the 1500s, is in the 1500s we ate once a day. And that is documented. Across Europe, we ate once a day. That meant even if you had an insulin response, you had 23 hours for the system to get back to normal. What we do now is we eat every 3 hours, and we're told to eat every 6. We're told to eat 6 meals a day. That means if it's carbohydrates, we get this insulin response. So every time we eat, we've got this hyperinsulinic response. And if you have insulin resistance, like people with diabetes like myself, the response is exaggerated. So every time you eat, you're damaging your liver and you're damaging your arteries. So my Damascus moment came when I read the book on the right, The New Atkins for a New You. And it was really interesting because I got this as an advert on email, and it said lose 6 kilograms in 6 weeks without hunger. And I said, well, I know that's false. You can't do that. To lose weight, you've got to be hungry and you've got to be a martyr and so on. And then I saw the guys' names, Westman, Finney, and Volek. And I said, there's a problem here because these are 3 of really good scientists. And they're associating their name with Atkins. And Atkins tried to kill us because he told us to eat fat. I said, there's a problem here. They've sold out to Atkins, obviously. And I got in the car because I wasn't happy that I was going to write these 3 excellent scientists off without giving them the chance to present their case. So I went immediately to the bookseller, and they had the last copy, and I bought that book and I read it. And within 3 hours, I realized that I'd been misled, and I'd misled the public. And I'd been misled because there was a whole history of the low carbohydrate diet and scientific evidence that I'd been completely ignorant of, although I thought I was knowledgeable. And I couldn't believe it. And that led me down this route, which I've gone. And there's Dr. Atkins himself, and that Dr. Atkins Diet Revolution is probably the best diet book that's ever written in my book. It's an astonishing book where he describes exactly insulin resistance. And so I now understand insulin resistance. And he describes it in 1972, and I knew nothing about it. And that's a failure of my education, both of myself and my people who taught me, because they didn't teach me this. Instead, they demonized this man and absolutely demonized him, as we'll discuss in due course. And that's not right. And so when I went to this book, it said there are 150 studies of the low carbohydrate diet showing benefits of low carbohydrate diets. And when I saw that, and I looked at the papers, and I went on the internet and copied them, and I saw these are high quality publications. And anyone who tells me that there's no evidence in support of the low carbohydrate diet simply doesn't bother to read the literature. The question that one of the expert witnesses that was not called, Professor Rousseau, and many people believe that actually you first become fat and then you develop insulin resistance. And I'm not going to suggest to you that this is definitive evidence, but I want to show you here that we were studying ketosis in the 1980s. This paper was submitted for publication in July 1979, published in 1980. Again, I emphasize Journal of Physiology is one of the leading journals in the physiology field. And here I am, my first 2 or 3 years. And as always, I'm one of the key experimental subjects. So what we did was, if we start from the left at 6 a.m., we came having fasted overnight, and then a colleague, another marathon runner, and myself, we ran for 2 hours around Rondebosch and Newlands, so it's very local. And on two different occasions, one when we had eaten low carbohydrates for 3 days before, and that's the yellow, and one when we'd eaten a high carbohydrate diet, the conventional athletic diet that I was prescribing, or I would have prescribed. And then we had a rest day in blue. And what you see is that when we ran for 2 hours and ate the high carbohydrate diet for the 3 days before, our ketone bodies stayed very low. However, when we ate the low carbohydrate diet, at the end of the exercise, our ketone bodies were 1, and then they rose to 2 or 3. And we both followed a very similar pattern. And this is nutritional or exercise-induced ketosis. And I want to make the point that this is a highly regulated system. And that as long as you have some insulin, as I do have, even if you're diabetic, you have insulin, if you're type 2 diabetic, you will regulate your ketone body levels between 0 and 3 or 4. So remember we'd fasted now since the night before, and we'd run for 2 hours, and then we could only get the ketone bodies up to 3. And you just cannot get values higher than that in a healthy person following any diet whatsoever, because the ketones themselves are hormones which make sure that they regulate their values. Diabetic ketoacidosis is a totally different condition. It occurs in patients with diabetes who have no insulin. They have very, very high glucose levels and their ketone values go up to 50. But it's not the ketones that are the problem, it's the acidosis that they cause. Because the body is trying to sort out this acidosis and prevent it, because you die if your pH drops too low. In other words, if you become too acidic, you die. And that's what will kill you in diabetes, is the acidosis. And it's a completely unregulated phenomenon. Now, if I was treating a patient with epilepsy, which I do not, but I understand the biology, or if I had a patient with cancer and was using a ketogenic diet for a cancer patient, you want to keep the patient with the ketone bodies of 3. And that is extremely difficult, because it means you have to cut the protein intake to extremely low levels. And you have to eat about 80% fat, which is a very difficult diet. And in extreme cases, you would want to do that. And then you could keep your ketones at 3 or 4. And it's safe because the system is regulated. You still have enough insulin. So I'm giving the idea that ketone bodies are highly regulated in the human body as long as you have insulin. And if you have the insulin, you will keep the ketone bodies within the normal range of between 0 to 4. And there's absolutely no evidence that that is dangerous for you at all. Well, just to put it in context, I'm on a 25 grams carbohydrate a day diet, which is a low carbohydrate diet. And I've just measured my ketones just to make sure we're all on the same page. And I'd just like to read into the record that at 7 minutes past 11 on the 2nd of February, my ketone body levels are 0.6. Now, we heard in expert testimony that if you're eating 25 grams of carbohydrate, you would be ketoacidotic. In other words, you'd have ketone bodies in the range of 30 to 40 to 50. And that's my ketone levels. And for me to get higher than that, I would have to cut the protein from my diet. I just make the point that I understand, I measure, I monitor these things. I don't just talk madly about them in an uneducated way. So that is nutritional ketosis. That's the range from 0 to 1 in people eating a low carbohydrate diet, which is not protein restricted and does have some protein, perhaps up to 10 to 20% of the energy as protein. That'll be the range here from 0 to 1. To get from 1 to 4, you have to run or exercise a lot, and you have to eat less protein and more fat. And the key is you have to keep the glucose in the liver at a very low level. And that means you have to keep exercising to burn up any glucose that is being produced in the liver. And these values, as I've indicated, it's tough to get there without starvation, fasting, and a high fat diet. You'll be in that range up to 4. Beyond that, to get up to beyond that, I would say between 2 and 5 might be the medical prescription of a ketogenic diet, between 2 and 5. And certainly if I had cancer, I would want my ketone bodies up to be 4 or 5, because I believe the evidence is that they have a role to play. And if I had a child who had severe epilepsy, probably you'd be trying to keep it in the same sort of range. But I've indicated that is a specialist medical intervention. In type 1 diabetes, where there is no insulin, the patients will become extremely sick once the ketone body is above 20 or 30. But that's because of the acidosis that the uncontrolled ketone body production causes. This is a regulated system, and I'll get back to this. Physiology is about regulation, about homeostatic regulation, how everything is kept in control. And humans are successful. Humans would not allow ketone bodies to go up to 3, as has happened here, if there wasn't a really good reason for it to happen. Because we've been millions of years in our evolution. And certainly we've been 3 million years in our most recent dietary evolution. And if we didn't have the ketone response, our babies would die and we would die in any period of starvation. This is a normal biological response that allowed humans to survive. So ketoacidosis comes once you have no insulin, and then there's no regulation. And you get the blood glucose controls go very high. Fat is continually released from the blood, from the fat cells. It goes to the liver, it swamps the liver starts to produce ketones in an unregulated way. And the ketones are acidotic, and acidosis then drops your pH. And ultimately, as the pH falls, you start to hyperventilate, you breathe excessively. That causes other abnormalities, and the system is unregulated, and you will die unless you're given insulin and a few other treatments to bring the ketones back under control. That is a medical emergency, and what's interesting in my medical training, just as an observation, I think we probably treated 3 patients with diabetic ketoacidosis. Today, I'm sure there are 5 people at Groote Hospital in diabetic ketoacidosis today. And that I mention that just to indicate the rise in the incidence of diabetes.
Now, Professor, you're on a 25-gram carbohydrate diet, and you've measured your ketones, and it's 0.6. Is that...
That is correct. And I can get my values up to 3 or 4, but I have to go and run for the whole day, and then I might just get it up to 4.
If it's 25 grams of carbohydrate, each gram of carbohydrate would be 4 kilocalories.
That's correct.
And therefore you are having 100 kilocalories of energy from your carbohydrates.
That's correct.
And a normal adult would have an intake, calorie intake of about 2,000 kilocalories.
If she's female, males probably have a little bit more.
So
yeah.
What would be normal for you then, Professor? For somebody
I eat 2,000. I eat 2,000 calories a day.
So if you're only getting 100 kilocalories carbohydrates and you need 2,000 kilocalories, I would estimate then that you are having 5%.
That's correct.
So 5% of your energy requirement is then coming from carbohydrates.
That's correct.
And that would be, how would you define that in terms of whether it's a low carbohydrate diet or a very low carbohydrate diet?
Even in my terms, that's the lowest we suggest you go to at 25 grams, because if you go below that, you're probably not getting enough vegetables and fiber in. So we've kind of restricted to 25 grams. So I would call that a very low carbohydrate diet. But even then, notice it's not ketogenic. Even though it is 25 grams and 5%, it's not ketogenic in the sense that it's producing ketone levels 2, 3, or 4, or 5.
Yes.
And certainly it's not producing the values of 50.
Now, Professor, with regard to diabetic ketoacidosis, which now is, would you agree, is diabetic ketoacidosis a pathological condition, it's a disease?
Absolutely, it's a disease caused by the absence of insulin.
And what would the levels of the ketone bodies be in that kind of situation?
Anything above the normal range, which goes up to 5 or 6. So once you go above 8 or 10, you just won't see those values in normal, healthy people with some insulin. Their ketone bodies won't go above 10.
Will a low carbohydrate, high fat diet in a normal person cause diabetic ketoacidosis?
No. So I've got so the final slide, so that was remember this is a study we did in 1979, and we measured some other things, and now going back on these data, I believe I can identify that I had insulin resistance present at the age of 28 when I was lean. I was running 140 kilometers a week, and I was insulin resistant. And the point is that I'm trying to make is that we misdiagnose insulin resistance because we don't really understand what it is. So there the ketone bodies, we've discussed those. So here now are much more complex slides. Now, the ketone bodies are generated by free fatty acids, which are released from the fat cells, which then come back to the liver and then are converted to ketone bodies. And predictably, when we were eating the low carbohydrate diet, our free fatty acid levels went up to 2. And that is also regulated because you can't allow them to go too high. And when we had the high carbohydrate diet, the values went up to slightly lower, and when we rested, of course, they were there. Now, what's really interesting, because I didn't see this when I looked at the data in 1980, none of us realized that we were seeing a phenomenon. Now, here we see these are the blood glucose levels, and diabetes is diagnosed incorrectly if it's diagnosed very late. Once you're fasting glucose, that's when you fasted for 12 hours, the glucose goes up and is above 6.5. So if these values were above 6.5, in other words, those values weren't there, they were up here somewhere. So if those values were there, we wouldn't have a problem. We'd say that you have type 2 diabetes. Our values are normal. What happened next is as we exercised, they rose, and that is wrong. Blood glucose levels should be tightly regulated during exercise, and for both of us, they should have stayed normal, but they didn't. They rose up to a value of 6, which is very, very unusual. I didn't recognize it, although I saw it. But now you see, when we eat the low carbohydrate diets, our glucose went up. Even though we hadn't eaten carbohydrates for 3 days, we were unable to regulate our carbohydrate blood glucose levels, and it only fell in the second hour of exercise, and then it was normal and dropped. So immediately, as I see that, I begin to wonder, can you detect insulin resistance in people by having them exercise and notice that their blood glucose isn't regulated? So that was the first, but then I noticed something even more interesting, and that is our insulin response. Now, when you have a normal insulin response, it should be below about 10. So these two values are normal. Those two values are normal, but this value is grossly abnormal. It's 3 times the normal. So when we did not do any exercise, for some reason, our insulin values were highly raised. And that is insulin resistance, and that's one of the ways we can detect it. It's a high resting insulin. So this, as you asked, advocate, you asked me, what's insulin resistance? You have to secrete more insulin to keep the glucose down. So here you see we've got normal glucoses, but the cost is we had to secrete more insulin. So it is my holding that we were both pre-diabetic, the 2 athletes that we studied, but we didn't realize it. We didn't realize we had insulin resistance. And that's why we're in such a predicament, is we underdiagnose the prevalence of insulin resistance and diabetes in our country. And we wait till the glucose goes up and all the other problems have happened. But this is when I'm 28 that I show this abnormality. So my theory is that insulin resistance is a genetic disorder that is present from birth. And we misdiagnose it. We wait till the person has got diabetes. And so that's the problem. And then again, look here, this insulin is still far too high. We haven't eaten all day and it's still very high. So my diagnosis is that Tim Noakes and friend have insulin-resistant hyperinsulinemia despite youth and marathon training. It improved on the high-fat diet. It improved on the high-fat diet. When we went on the high-fat diet, low carbs, we were better. We didn't have as much insulin, so that was helping. And they must develop type 2 diabetes with time if they continue eating a high-carbohydrate diet. And one of the talks will be on what's this condition of hyperinsulinemia, insulin resistance, from which I suffer, and which I will show is the most prevalent medical condition on planet Earth, but which is included in the medical curriculum and taught at few, if any, medical schools around the world. And I will argue that this is the most prevalent condition, and it's worsened by high carbohydrate diets. So we have the situation, we have a predisposing condition, insulin resistance, which we don't recognize. We underdiagnose it. It was underdiagnosed in me. And then we provide a dietary advice that makes it worse.
In your view, and having perused all of those articles and the research that goes in the formulation of those guidelines, do you believe that sufficient or any consideration was given to this highly prevalent condition of insulin resistance?
No, I don't think so. I think the guidelines are prescribed as if everyone has perfect insulin tolerance and can metabolize carbohydrate well. And that would be fine if the population was 100% insulin sensitive. I would have no problem with the dietary guidelines. But because they don't consider the individual with insulin resistance, and they completely continue to ignore the individual and what that person needs, then we have a problem. And I will show you why it is. It's because there has been a health washing of carbohydrates over the last 60 years. when people started to demonize fats, they had to make carbohydrates healthy. And I will show you that there's plenty of evidence that carbohydrates were not healthy. But because of the dietary guidelines in 1977 and the political influence that brought about those dietary guidelines, carbohydrates had to be health washed. And so we had to say these are going to be healthy for everyone. And that ignored the reality. And we're in the predicament we are today because we didn't understand that we're prescribing the wrong foods to people who can't metabolize carbohydrates successfully for 60, 70, 80 years.